I want to take a step back a little bit and talk just for a moment about the t-statistic, the t-distribution, or in this case just the t-statistic. And I want to introduce a little reconceptualization, I think, about it as a ratio, and I'll explain. If we were doing independent samples, we would compute these various terms, the means of the two groups, the variances of the two groups, the numbers of observations, the sum of squares, etc., etc. And we would calculate this pooled variance term. We would calculate this estimated standard error here, and so on and so forth. And then we could compute the t doing this formula. In the dependent sample t, which we sometimes call matched pairs or paired t-tests or correlated samples or repeated measures or within subjects, we compute these various terms, the difference, the number of pairs of scores, the mean difference, and the standard deviation, estimated standard error, and so on. And then we would compute the t-statistic this way. Now, what is this t thing? Well, in both tests, the numerator is a measure of the observed difference between scores. Okay, this is the difference between pairs of scores. This is the difference between means. And in fact, they're identical. The mean difference is equal to the difference in means. The denominator of both tests is an estimate of the standard deviation of the sampling distribution of the differences. We call it standard error. Now, why does it? What is this error thing? Why do we call it error? We've been talking about errors in hypothesis testing, but this is a different sort of error. It's an unfortunate use of the word error. I think what we should call it is something like standard deviation, or estimated standard deviation, or something like that. But what it refers to is when we take a sample from a population and compute a statistic, and if we do this again, and we do this again, and we do this again, and we do this again, we don't expect to get the same exact statistic, for example, mean, every time. If we take a sample from a population, compute a mean, then take another sample from the same population and compute a mean, we don't expect those means to be identical. There's going to be slight variability. Okay, a certain amount of variability is to be expected. No two means are exactly alike. This variability from sample to sample is what we call the error. And it can be estimated based on certain situations. It can be estimated based on our sample. Okay, and the reason that we can estimate that is that we can standardize it. We can compute a standard deviation. So we're standardizing the amount of error. Now, the error from sample to sample can be very large or can be very small. So, just by chance, we can get a difference between two means that because we expect not a lot of error. The error can produce large differences between sample statistics just by chance. So we could have an enormous difference between sample means. But if we're looking at an enormous spread of scores, we might expect a lot of variability between means. So we're using the sample standard deviation to estimate the standard deviation of the sampling distribution, right? Because of the second amazing fact. But it could be that large differences in the population, a lot of spread in the population, probably means that there's going to be a lot of spread in the means. In fact, there is going to be a lot of spread in the means. That's what the second amazing fact says. So, I want to reconceptualize the t-statistic as a ratio where we think of the top term, or the numerator, as our difference obtained between two means. But then the denominator is the difference we expect by chance. Okay, and sometimes this is going to be large, sometimes it's going to be small, depending on how much variability is in our sample. We're going to use that sample variability to estimate the sampling variability of the sampling distribution. And the t winds up then as a ratio between these two variances, the obtained difference and the difference expected by chance. Okay, we're going to return to this conception of what a t-statistic is in a little bit, but for now I just hope you see that relationship. All right, talk to you soon.